Good morning. We're going to look at graphing solutions for quadratic linear systems. So, if you remember from Algebra 1, a system of equations is where you have two functions on the same graph. And then you look at the point where they intersect. So that would be the solution. Or let's call it solution point. And then down here I'm just going to write enter. That should be an S. So that's the intersection point. So the point where the two graphs cross each other. So let's look at the number of solutions we can have. So I can have a quadratic function of some type, maybe something like that. And then I can have something linear that crosses over. And you can see when it crosses over, it makes points of intersection. So those are solutions. So in this case, we have one here and over here, so we can have two solutions. Let's look at the next example we can have happen. Let's put a quadratic up, kind of like that. And then we can have a second equation that comes across like that. Now, they only touch at one point down there. So 1 point, one. So in other words, this is one solution. Because they only intersect here. So this is the intersection. All right. Now we can have a second. We have two. Now we're going to have a third. Is what I meant to say. Third example. What if we had something went kind of like that? That's crazy looking, but that's okay. You get the point. And then we had something that was like this. They would never cross. Right? So in this case, this one has no solutions. So this one has no solutions. So these are the three types of solutions or numbers of solutions that you can have in combination. So let's take a look at this, what we have here. Oh, we're going to graph both of these. So the first one I'm going to graph is the linear one. So I know the y-intercept's at 1. And then it has a slope of 2. It means I count up 2 from that point and over 1. I could count up 2 again from the second point and over 1. I can even take from the first point, count 2 down, and to the left 1, because down is negative and going left is negative. So with those done, I can actually go ahead and bring in my graph. Didn't mean to do that one. I come in and bring my graph. Ooh, you don't want to connect with me. There we go. And put it through its points. These are off a little bit, aren't they? Right, now we're cooking with gas. Back on track. Alright. So let's finish moving our coordinate line, our function lines in here. Make sure you take it all the way across the graph because I don't know where the other function is going to be. So we're just going to go ahead and start off by graphing it all across. Alright, so once I have that in place, I need to graph this quadratic over here. We know what we need to do here. We've been doing it for a couple weeks now. We're going to use the vertex equation. So to find the x value of vertex, we know it is negative b over 2a let's go ahead and set that up. So that means we're going to have negative 2 over 2a. So that's just over 2, so that's negative 1. That's my vertex, x value. I need to take that, put it back in, so y is equal to negative 1 squared plus 2 times negative 1 minus 3. So if we look at this, we get 1 plus a negative, we'll do it that way, plus a negative minus 3. So this is negative 5 plus 1. So we're at negative 4 for my other value. So negative 1, negative 4 is the vertex. So negative 1, and then we gotta go 1, 2, 3, 4. And that's the first point on our parabola. Okay, so I need a couple other points. Remember, this is also my axis of symmetry. So if I put in 0, I get negative 3 as my y-intercept. Also get it over here. Okay, let's get 2 more points. And the other 2 points I want to get, we're going to get by factoring this. Now, you guys have had enough practice in factoring. Some of you guys can just see that the zeros for this case are going to be at 2 numbers that make negative 3, but have will have a difference of 2 and make a product of 3. So it's going to be x minus 1, x minus, x plus 3. Okay, so that means I'm going to have an intersection point. Remember, we set that equal to 0. I'm going to have an intersection point at 1. And then I'm going to have another one at negative 3. 1, 2, 3, so right there. So that kind of gets me crossing this, and I can guesstimate. All right, so if we go ahead and graph or draw a sketch of the quadratic, may look something like that. Remember, it is just a sketch. So since it is just a sketch, identify our solutions. One here, one up here somewhere, probably a little bit, I don't know, a little bit to the right. But that also shows that we have 2 solutions. Okay, let's look at another example of what we could get. Oh, we could get this. If we look at this, this is in vertex form, so we know where the vertex is for this one. We're going to graph our quadratic in black. So our vertex is at negative 2, negative 6. 1, 2, 3, 4, 5, 6. Okay. We have a y-intercept also at negative, at 0, negative, that can't be our vertex, right? Our y-intercept. Our y-intercept is when we put in 0 for x. So this is going to be 4 minus 6. That's going to be at negative 2. And we're going to go 1, 2, and this would be the axis of symmetry. 1, 2. We can put a point right there. Okay, so kind of with those 3, we can sketch our graph. Okay. But let's go ahead and find our zeros. I just want to be sure. So if we make y equal to 0, we're going to end up with some radical number. So let's stay away from that. We're just going to go ahead and sketch our graph because this isn't accurate as if we actually did the math to solve it, which we will do in the next section. So negative 2, that's our point of intersection. Now our slope is 4, so that means I can go 1, 2, 3, 4, and over 1. Right there. So now if I'm going to bring a line in and draw a line through, let's put this line on our graph. That line needs to go through both of those points, right? So it has to go through both points. So we're going to draw that one up. Now we're going to take this one, bring him all the way down, and center him up a little bit better. So look at that. It only has 1 point of intersection. Doesn't have 2 points of intersection. Only 1 point of intersection. So we can also have a situation like that where it cuts through 1 point of intersection. Okay. So let's go ahead and take a look at our next page. Oh, didn't mean to erase that. Let's put that back up. I meant to go to the next page. Did I go to the next page? Huh.